Hello, so this is my redo of the advanced hypothesis testing. So for this, there had to be 3 tests repeated. The first one was pair data analysis, the second was multiple population means analysis, and the third was variance comparison analysis. I'm going to show each of them since it's all one code, I'm going to show each of them in their sections, and then I'm going to explain them while I'm going through it. So the first one is, so right here I'm importing all the libraries that I need for all of them. The first one is about a video game called Cooking Cats. So the problem is what the output would be for the video game itself, and what the test should be what test should be performed. The question would be what test should be performed in order to figure out the results. And the system approach would be normality and non-polemic. So here is the Cooking Cat CSV file. So this is its name. So there's 2 versions, the date 30 and the date 40. So as you can see, that's here. The shape is 901, 89, and 5. There's no duplicates. And then the mean is 50.59 and then 53.14. And then here you can see the sum of both of them of the game rounds, so 51.97. The first part is the hypothesis testing, so the version, which version it was, the rounds, and the count and the mean. So for version date 30, the count was 2,503 and the mean was 52.29. The second one was date 40 and the count is 2,497, and then the mean is 51.64. The first part here is the normality result assumption. So the version and the day rounds for the p result. So the version, so the date 30, that's the version we're looking at. The stats result for that is 0.468, and there's no p-value. And the version for the date 40 version, the stats is 0.49.8, and the p-value for that is 0 as well. So the next part is a non-polemic test. And so the version, so the date 30 and the sub-rounds. So it's combine the two, or so find the value in between the two of them. So date 40, the sub-game rounds. The statistical value is 3120414. 500, and the p-value is 0.92. That is the value for both of them combined. So that's for part 1. Now for task 2, the multiple population means analysis. So the problem is, this one was the A-B test. So it's about a test. Problem is, what are the test results for this test? The research question, what variant, is it controlled or is it a regular variant? And statistical morality and polemic. That's going to be for all of them. So right here, it's reading the CSV file, as you can see. The description for the user ID and the revenue, so the count, the mean, the SCD, the min, 25%, 50%, 75, and max. So that's all these values. So it's sorting the revenue. So the user ID, variant, and the revenue. So I see those are the results. The duplicate, so I got rid of the duplicates if there were any. Revenue and variant name, so that's showing the results here. Right here, variant control and variant and the regular variant, so just control the 2 of them. The control one is 380,973. Mean is 40 for the user ID, 4988.03, and the standard is min, max, that stuff. User ID to the count is 3960, mean is 4965. The revenue is 39.60 and 0.008 is the mean. So the hypothesis testing, the control for the revenue is 0.1618, and the variant revenue, the mean for that is 0.088. So the normality assumption, so the test value and then the p-value. So the test value for the first one is 0.02. So this is the revenue, controlled revenue. 0.0220, and the p-value is nothing. The variant where we use the linear variance, so this is the Shapiro method that we're using right here, is 0.0327, and the p-value is nothing as well. This is the test stats for both of them, so we combine the two as well. And you get the test stat. So the test stat is 78.823, p-value is 0.5129. So this is the YAS test for the advanced hypothesis testing. So this is the variant comparison analysis. So for this one, it was for a marketing campaign. So the problem is how when the marketing campaign results came out, and the research question. So the marketing campaign is based off fast food, so it's the sales that are in each fast food, and then the results, the stats is the parent results. So right here is all it's loading the CSV file. Fast food promotion. So here 1, 2, and 3, that's 3 different parts of this section, so we're going to find those values. So the first one, 188, the third one is 188, the second one is 188, and the first one is 172. Promotion 1, Promotion 2, and Promotion 3. These are the names for up here, so it's smart. Normality assumption. So it's going to be in groups. So as you see up here, see how it's Promotion 1, Promotion 2, Promotion 3. Down here it's going to be 3, 2, 1. So the p-value for 3, the p-value for 2, and the p-value for 1. These are all 0 because we haven't done that far into it yet. The non-polemic test, so it's going to be promotion sales in thousands. So the first promotion sales in thousands, the second promotion sales in thousands, and third promotion sales in thousands. So with those results being said, it's going to show the results of all of them combined. So the statistical value is 53.295 for all of them, for all these promotion values. And the p-value is 0, as mentioned before. Down here, this little section here, the multi-comparison, is what we were looking for this task, which is what I'm showing you right now. So the comparison, multi-compare, sales in thousands, and the promotion. So as I mentioned in the previous section, this part here, as you can see, group 1, group 2, so it's 1, 1, 2, 2, 3, 3. That's telling you where it falls. So the means, the yellow and the upper and the reject, if it's rejected or not. So that's what the promotion, the multi-comparison for each of them is. So group 1, 1, 2, the mean, yeah. So that's all this right here.